Well, this lesson's about finding probabilities of disjoint and overlapping events. You'll see that I have three illustrations here on one, two, and three, illustrating three different possibilities for how two events can come together. So if we have a compound event, meaning more than one event, those events can either come together and share some some of the outcomes, or they may not share outcomes. If they share outcomes, then we can talk about two different things. We can talk about how A is in union with B. So if I was interested in all of the outcomes in event A, as well as all of the outcomes in event B, we would be talking about the union of A and B. If I'm just interested in what the events, what outcomes both event A and B share, then I'm only interested in where they actually intersect. This is their intersection. All right, so in illustration one, we're talking about in union, the union of A and B. What are all the events that can happen in either A or B? In intersection, we're only concerned with what can happen in A and B. And then illustration three shows when the events A and B do not share any outcomes. Nothing is going to be similar between those. When that happens, the intersection is, we say it's empty. So there's nothing, no outcomes where they share together. This intersection part in A and B is empty, and we just illustrate that by drawing separate circles. Okay, so this is union of A and B. This is the intersection of A and B. And this, even though they're not sharing anything in common, what we would say is the intersection of A and B is empty. All right, so we can determine the probability of certain events happening and their outcomes with a couple of formulas. So the probability of A or B, so either A happening or B happening, we have to consider what outcomes are in the intersection of A and B. So what are they sharing in common? If they are sharing some events, some outcomes in common, then we can follow this formula right here. All right, so it looks complicated, but really if we kind of break it down and explain what each of these parts is referring to, it becomes a little bit more understandable. So if we have two events coming together, A and B, and we want to know the probability of either A or B happening, so either one, then we're going to take the probability of A happening and add that to the probability of B happening and subtract from that the probability of A and B. All right, so that takes into account what they have in common. You're subtracting that out from what they do not have in common. The other scenario is that represented here. If there are no outcomes in the intersection, so that's referring to illustration number three, then the two events have no outcomes in common and are called disjoint. So this is illustrating disjoint events. If that's the case, then they don't have anything in common. There's not any probability of A and B because it's empty, it's zero. So then we can just take that subtraction part from the formula out here, and you just are left with the probability of A or B happening equals the probability of A happening plus the probability of B happening. All right, so it becomes, the formula is a little simpler if they are disjoint, if they do not share any outcomes in common. So going up to number 1 through 3, the directions tell us that events A and B are disjoint. So that's like the illustration in number 3. They want us to find the probability of A or B. Well, since they're disjoint and they do not share any outcomes in common, then we are going to use this formula right here, where if we want the probability of A or B, which is what they've asked us for, all we have to do is take the probability of A and add it to the probability of B. So that would mean we're taking the probability of A here adding it to the probability of B to get the probability of A or B happening being 0.55. Right? Same thing over here. In number 2, they gave us the probability of A and the probability of B. They told us they're disjoint. They want to know the probability of A or B happening. So we're just going to add them together to get the probability of either of them happening. One or the other is at 0.9. So now in number 4, they just tell us to find the indicated probability. They do not tell us whether these events, these two events, A and B, are disjoint or not. We will find out when we do our calculations because they've asked us to find the probability of A and B. So this, once again, because we don't know if they're disjoint or not, we're going to need to follow this first formula over here, where they tell us that the probability of A or B equals, so I'm going to come over here, the probability of A or B they gave me here. They said it's 1/3. That's going to equal, over here, the probability of A plus the probability of B. They gave us both. Probability of A, probability of B. And then the formula says I need to subtract the probability of A and B from that, which that is what they've asked us to find. All right. If these are disjoint events, if they don't share any outcomes in common, this number is going to come out to be 0. The probability of A and B happening, it's not existent, because if you see in illustration 3, they don't share anything, any outcomes. So we'll find out when we do the calculations. All right, so I'm going to end up with, let's see, 1/3 equals 6/6, or 1. 1/6 plus 5/6 minus the probability we're trying to calculate. Subtract that 1 off both sides, and then I'm going to have to divide through by -1 to get rid of the negative sign here. So without showing all that algebra, we're going to end up with a probability of A and B at 2/3. So these are not disjoint. They do have an intersection that has some outcomes in common. The probability of A and B happening is 2 out of 3. All right, we'll do the same thing on number 5. Again, they've asked us to solve for the probability of A and B. We don't know if they're disjoint. They haven't given us that information, so we're going to need to use the same formula. So the probability of A or B they gave us at 0.25. That's going to equal the probability of A plus the probability of B minus what we're trying to solve for, the probability of A and B happening at the same time. All right, so we're going to add, subtract, do all our algebra to solve for the probability of A and B. And that, all said and done, calculates out to be 0.34. So again, these are not disjoint. There is a probability that is not 0 of both A and B. So we're looking at a situation like number 2, where they do come together and they do have an intersection. That intersection is where they share their outcomes, and the probability in this case of that happening is 0.34. So just as we can talk about the probability of an event happening, and the outcomes involved in that, we can also talk about the outcomes involved in the event not happening. And that is called the complement of an event. All right, and that is illustrated here in these directions where you see for 7 through 9, where you see the probability, and in parentheses you see an A with a bar over it. That is actually read the probability of A bar. All right, so it's not anything difficult to remember. So this is the probability of A bar, and that is going to include all of the events that, all the outcomes that are not included in the event. And it comes with its own formula. So the probability of the complement of an event is going to have its own formula. So this is the things that will not be in the event. So the complement of A, all right, is going to be the events that are not included in event A. We're going to call it, we're going to write it like this, probability of A bar. And the formula for that is 1, all right? 1 meaning like um, 1 in probability is like 100% chance that the actual event is going to happen. So if we take that 100% or that 1 and we subtract from it the probability of A happening, then we will be able to calculate the probability of A not happening. Okay, the outcomes that are not in A. All right, so this is the formula when they ask you to find what is not in A. And we'll get to that a little bit later, and it'll make a little bit more sense when we look at a problem on the back of the worksheet. But until then, let's just go ahead and put that formula into practice. So if they've told us the probability of A in number 7 is 1, then the probability of not A, the complement of A, so the probability of A bar is 1. Take away the probability of A, in this case, that is 1. That means 100% likelihood of A happening, the events in A happening. You're going to get a probability of the complement happening of 0, which makes sense there if you think about what the 1 actually means in probability. The probability of A is 0.25, so the probability of A bar, the complement, the things that are not included, the outcomes not included in A, would be 1 minus 0.25 or 0.75. All right. Now, if we come down to number 10, then now they're talking about stating whether A and B are disjoint events. So if we go back to that definition of what disjoint events means that we talked about at the beginning of the lesson, disjoint means that no outcomes for A and B they're not going to have anything in common. That was illustration number 3 at the top. The intersection was empty. So the probability of A and B in that event is 0. We can look right here. They've given us the probability of A and B at 4/13, 4 out of 13. And so these are definitely not disjoint events. They have a probability of some of their outcomes occurring together. So these are not disjoint. All right, the second part of the question, or really the first, was to ask you to find the indicated probability. These are no different than 4 through 6, except for the fact they're giving you different information. Now up in 4 through 6, they gave you the probability of A and the probability of B and the probability of A or B and asked you to find the probability of A and B. Down here, they're wanting you to calculate the probability of B happening. So they've just left a different variable open. We're going to use the same formula that we used when the intersection of A and B, when they're not disjoint. Okay, so this formula that we used up here on 4 through 6. So we're just going to fill in what we know. The probability of A or B, I'm sorry, is 8/13. That equals the probability of A at 2/13 plus that probability of B, which we don't know. That's what they're asking us to find. And then we're going to subtract from that the probability of A and B happening together, which is 4/13. So you're going to have to, work with these fractions a little bit here. All of the denominators of this are equivalent, so it makes it a lot easier. Okay, so we can see that the probability of B happening, it comes out to 10/13. Okay, so two-part question. They're trying to make sure you understand what disjoint means in terms of actually being able to look at those probabilities. So moving to the back, we can get to the practicality of how all of this comes together, and it hopefully will connect some dots for you here. Make sure you're on page 709 in the textbook for this section. They have a diagram there of all the outcomes possible, the 36 possible outcomes if you have 2 6-sided dice that you're going to roll at the same time. So it gives you all the options of the outcomes that can happen there. And we need to have that so that we can do these problems. So your you've got two six-sided dice are rolled. Find the probability of the given event. In 13, they want you to find the probability that the sum of those two dice is going to come up to be greater than 4. So we've got just one outcome here. What is the probability of the event being the outcome of the event being a sum that's greater than 4? You can figure out how many of the 36 options there are by going to that first column and of dice. So there are 5 columns. Go to the first column. I'm sorry, there are 6 columns. Obviously, there are 36 options here. So 36 columns, 6 rows. You go to that first column and you follow it down until you get to the first sum that is greater than 4. So that should be 4 rows down. All right, so everything from there, if you kind of like draw a diagonal line from that first possibility of where it's greater than 4, and you kind of draw a diagonal up, you can get the line that's going to like kind of cut off the options that are not going to be greater than 4. Okay, and out of those that are not greater than 4, you can see there are only 6 options. Okay, the rest, there are 30 possibilities then of these dice rolling out to have a sum of greater than 4. All right, so because there are 30 possibilities, 30 outcomes that are greater than 4, we're going to put that number over the total number of outcomes. So remember, this is just the basic definition of probability. The likelihood that the event we want is going to happen over the total number of outcomes possible. And we'll reduce that down to 5, 6. So we know that there are, out of every roll, there's going to be a 5 in 6 chance of rolling a sum that is greater than 4. If we move over to 14, now here they're asking us for the probability that the sum is 6 or 11. So now we have 2 events. Okay, so we've got the probability of A happening or the probability of B happening. All right, so if we want the probability of A and B happening, then we need to, A or B happening, we have to add those 2 probabilities together. So this is like the idea on up above that we were talking about when there is no intersection, right? They're disjoint. They're not going to both happen. It's either one or the other. So we're going to take the probability of A and the probability of B. So going back to the diagram on 709 in the textbook, we need to find the probability of A. So we need to know how many possibilities, how many outcomes there are for the sum to roll out to be 6 total. So if you go to the first column and just run down that column until you get to the first set of dice that roll out to be 6, which is 5 down. So first column, 5 down. If you just draw a straight line, a diagonal line up through that column, you can see all the possibilities for the outcomes for rolling 6. So the next one over, the next column over, you can see that a 2 and a 4 will roll out to be 6. The column over from that, 3 and 3. The fourth column would be 4 and 2, and then that fifth column, the very top outcome, 5 and 1, is the last possibility to roll 6. So you've got 5 outcomes that will give you a sum of 6 out of a total of 36 outcomes, 36 possibilities. We're going to add to that the probability of event B happening, rolling an 11. So you have to do the same thing. There's not as many outcomes, of course, for rolling an 11. So if you scan all the way over to column 5, down at the bottom, the last outcome in column 5 is a 5 and a 6. So there's your first opportunity for 11, and then if you just go up diagonally, you can see the second option in row 6, in column 6, row 5, a 6 and a 5. So there are only 2 possibilities, 2 outcomes that are going to give you an 11 out of the 36. So that outcome of I'm sorry, the probability of A plus the probability of B gives you the probability of A or B happening at 7 out of 36 rolls.